Okay, so we've all seen this painting, right? But what if I told you we're about to look at it in a way you never have before? Now through the eyes of an art historian, but through the lens of physics. Yeah, you heard me. We're going to uncover a secret, a scientific masterpiece that's been hiding in plain sight for more than 100 years.
And here it is, Van Gogh's The Starry Night. I mean, it's just iconic. You feel that swirl of raw emotion, the insane color, the sheer energy. And for, what, over a century now, art experts have told us it's a window into Van Gogh's famously turbulent mind.
But what if that turbulence isn't just a metaphor for his feelings? What if Van Gogh, in this burst of creative genius, actually painted one of the most complicated ideas in all of physics? And get this, decades before scientists even had the math to fully explain it. How crazy is that?
All right, let's get into it. To crack this mystery, we have to look past the beautiful brushstrokes. We're on the hunt for something else, a very specific scientific pattern, and it's hidden right there, deep inside those famous swirls. So, what are we looking for? The concept is called turbulence, and you see it everywhere. You just might not know the name for it. It's that chaotic, swirling motion you see when smoke rises from a candle, or when a river gets rough, or even when you pour cream into your coffee. At first glance, it just looks like a total mess, right? Pure chaos.
But here's the cool part. It's not just chaos. Physicists figured out that inside all that swirling mess, there's actually a hidden mathematical rule. It's a rule that explains how the energy from the big, powerful swirls kind of tumbles down into smaller and smaller swirls, these little eddies, until all that energy just fizzles out.
And this rule, it has a pretty fancy name. Call McGroth turbulent scaling. Don't worry about the name. Just think of it as a fundamental law of physics for how stuff flows. And that law, that's the scientific fingerprint that a team of researchers decided to go looking for, right in the middle of Van Gogh's masterpiece.
Okay, so how on earth do you test a painting for a law of physics? I mean, where do you even start? Well, you have to do something kind of radical. You have to stop looking at it as a painting and start looking at it as a physical system. You basically have to turn this beautiful art into cold, hard data.
So the big challenge for these researchers was figuring out how to translate Van Gogh's visual language, his brushstrokes, the colors he chose, the way he laid everything out, into the mathematical language that a computer could understand, the language of a fluid dynamic simulation.
And they got super detailed with it. They broke the whole thing down piece by piece. They literally counted every single major vortex or swirl in that sky. They counted every star plus the moon. They measured the exact size of those glowing halos. They even calculated the exact shade of that deep cobalt blue that dominates the painting.
And as they were doing this, they stumbled onto something pretty amazing. They found there are exactly 11 big swirls in the sky. And, what a coincidence, there are also exactly 11 bright objects. That's 10 stars and the moon. These weren't just random numbers. They became crucial inputs for the computer model.
So every little detail, from the width of the painting in pixels all the way down to the radius of the moon's halo, every single one became a parameter in their model. It's like they captured the soul of the painting and translated it into a list of numbers, all ready to be plugged into a physics engine.
Okay, now this is where it gets really, really cool. They've turned the painting into data. Now they can finally run the simulation. The big question was, could a computer, using only the laws of physics, actually recreate the unique vibe, the look and feel of the Starry Night?
And, wow. Just look at this. This is the result. On the left, you've got the light from Van Gogh's actual brush. And on the right, that's the light field generated entirely by the physics simulation. I mean, the similarity is just stunning. They're practically identical. It's unbelievable.
But they didn't stop there. They went even deeper. What you're looking at now is the vorticity field from the simulation. That's just a fancy way of saying it's a map of how intense the swirling is. And this is key. The simulation didn't just copy a flat picture. It actually reproduced the dynamic, swirling movement that makes the painting feel so alive, so full of energy.
And right here, this is the smoking gun. This graph is the final proof. Okay, so those colored lines, they're tracking the patterns of light and dark in Van Gogh's painting. And that dashed black line, that represents the perfect mathematical model of turbulence. Just look at how closely they match. It's nearly a perfect fit.
So, what does this all mean? It means that the way the brightness changes from one point to another across Van Gogh's canvas follows the exact same mathematical rule as the way energy moves around in a real turbulent fluid, like rushing water or wind. It's just mind-blowing.
He painted perfect turbulence, and he probably had no idea. Okay, so this is all incredibly cool, but you might be thinking, why does this actually matter? Well, it's more than just a fun piece of trivia. This research, this bridge between art and science, it actually has some really big implications.
I mean, really, why go to all this trouble? Why build a super complex functioning physics model of a painting from the 1800s? What's the big takeaway here?
Well, the answer is a whole lot of people benefit. Think about it. Physics teachers now have this amazing, beautiful way to explain a really tough concept. Art historians get a brand new data-driven tool to look at artistic style. And for folks in computer vision and machine learning, they can use this model for all sorts of things, from creating AI that can mimic artistic styles to even helping authenticate artworks.
And the future possibilities are just awesome to think about. Imagine going to a museum and playing with an interactive exhibit where you can crank up the turbulence and watch the sky in the painting change right before your eyes. Or what about training an AI that can look at a painting and tell you, yep, that's the super turbulent style from Van Gogh's later years versus his earlier calmer work? The potential is huge. So we started this whole thing with a painting we thought we knew, but by looking at it through this new lens of science, we end up seeing it with completely new eyes. It's not just a work of emotional genius anymore. It's also this incredible example of profound intuitive scientific accuracy.
And all of this leaves us with one last, huge question to chew on. Did Van Gogh's mind, at its most brilliant and chaotic, somehow tap into the deep mathematical laws that run our universe? Or is it something even bigger? Maybe the patterns we find so beautiful in art are beautiful because they echo the fundamental structure of reality itself. It really makes you think, doesn't it?